Welcome back to Biodiversity Boutique. And you guys are from Stepping Stones in Grand Rapids, Michigan, and we are at Grand Rapids Community College. And we're going to talk about birds today, right? So we've had a little bit about birds, and now we're going to go into more detail. I'm going to ask you all sorts of questions that you guys can answer. First of all, what is a bird? Bird, what is it?
A bird is an animal which lays eggs, has
Okay.
feathers, and wings, and hollow bones.
And hollow bones, that's very good.
They also have ear sacs on their skeleton, make them buoyant, I think.
Okay. So that's the end of the lecture then, we're done. Okay. What else? What's a bird?
It's an animal.
Oh, sorry. It's an animal with hollow bones usually, and air sacs, and what else did you say? Feathers?
Feathers and lay eggs.
Okay, so remember a long time ago they put birds, it's obviously an animal, right? And they put birds in a class. Does anybody know what they call that class? Aves, okay, so it's aves, but you know what they did when you guys weren't looking? They changed the taxonomy. So now birds are a subclass of reptiles. Now why would they do that?
Because they're the same from dinosaurs.
From dinosaurs. Okay, so if you put them in the reptiles, that makes it good then, right? Everyone agree with that? So what you're telling me then is that birds are fancy dinosaurs? So why do they put dinosaurs in one group and then birds in another? I mean, is there something special about that?
Because they evolved to have feathers.
They evolved to have feathers. All right, so let's go way back. Did any dinosaurs have feathers? Did they?
Yeah.
And
So some had like Archaeopteryx and Velociraptor.
Velociraptor, okay, and those are a kind of dinosaur, right?
Yeah.
And they had feathers. And in fact, a lot of those, what they call theropods, right? Theropods, the ones that have the sort of reptilian hips, not the bird hip ones like stegosaurs, but the ones that had dinosaur hips. They were related to birds. So why don't we make a new category for birds and dinosaurs? Why don't we do that? Do you think that'd be a good idea? What do you want to call it?
Well, I was going to say why they didn't do that, because dinosaurs are reptiles, actually, and also related to reptiles.
Okay, so they're part of the reptiles. But you know, everyone says dinosaurs are extinct. And I always get confused because you guys just told me that birds are kind of like a dinosaur. So,
They're not. Like, the whole dinosaur, is it a reptile, is a huge debate because some people think they're warm-blooded, which would make them not reptiles, but a lot of people still think they're cold-blooded,
really?
which would make them reptiles, and no one knows what to say about it, really.
Okay. So we have some problems here, don't we? We have some problems understanding, you know, where they came from. So I'm going to help you out today. I'm going to point to some, you've seen this actually before, Archaeopteryx. And we're going to go through it now, and maybe you'll remember some of the things we talked about earlier. And then I'm going to show you a bird skeleton, the pigeon over here and the chicken, and I'm going to ask you what's different about it, okay? So you ready to go? So we're going to use this fossil worth millions of dollars. Actually, that's not, is that a cast or? So I went to the Field Museum in Chicago just past weekend, and I saw, I don't know if it was a real, I think it was a cast really, but it looked really real. I don't think they have one of the original ones. I think there's only like 7 in the whole world, and I don't think they have one. But I did see Sue. You guys know who Sue is, right? Okay, who is Sue?
It's the largest complete dinosaur.
T-Rex.
T-Rex, that's it,
T-Rex,
that's it. Did you see Sue? Have you seen Sue? So, pretty big dinosaur, right? And big claws, big mouth with big teeth, and probably eat, most of you guys like popcorn, right? Just throw it up in the air and go, okay, I could use 2 or 3 more as an appetizer, and then go on to something big like stegosaurs, right? So it wouldn't be worth their time to chase you down probably, right? You're just too small. So what you are telling me is that this creature here is related to Tyrannosaurus rex, right? And we know that some of the relatives of T-Rex had feathers, but they ran down their head like a bad mohawk, or sometimes they were on their hands, you know, or they were on their body, very small feathers, or they were on the end of a long tail, but they probably couldn't fly because the feathers didn't go all around their wings, right? All right, so let's look at this thing from head to tail, and we'll see what we've got here. Okay, you ready? So you think dinosaurs, you know they have scales, right? And they have big teeth. And the teeth are kind of like this. They have a big tooth and a cup. So these are called thecodont teeth because you can pull them out. The teeth is like a cup. So now let's look at this thing here. Now you guys can't see it here, but I can see it. I see a whole bunch of teeth, and they're in cups like this. So do any birds today have teeth? None. So when you hear that phrase, rare as a hen's tooth, or hen's teeth rather, does that mean that some hens have teeth? You don't think so? Well, they think that the genes that make teeth are still in birds, and so once in a while, apparently, as they're developing, you can see little teeth here, kind of like a whale. You know, a baleen whale has teeth, but they disappear, and then they develop the baleen, you know, to strain out the shrimp-like creatures from the water. Well, these guys have distinct teeth, so that's not like a bird, is it? What do you think? No? And then if you look at the face here, the face has scales. So do you see any scales on birds today, on their face? None? You sure? You sure?
Actually, chickens have scales.
Do they?
Yeah.
Well, I've never actually seen any, but maybe you're right. I mean, it could be. But I don't think they're there for most birds. I think that they're mostly small, very small feathers, which are like a scale. Okay, now, here's the eye there. It's a weird eye because it has this ring of bone-like plates there. It's called the sclerotic ring. Sclero means hard. And it's big. So when you look at the head of a bird like this one right here, that ring is gone, but look how big the eye is. I mean, it's huge, isn't it? In fact, I can pinch this skull like this, and there's nothing in between, is there? And you don't have that bone in the middle of your brain, do you? Remember Professor Krieger when he was talking about your brain, and you had the jello brain, you had the cerebellum in the back and the cerebrum on the top? Well, this doesn't look like it has much of a brain, does it? Mostly eye. So do you think their vision's pretty good usually? That's what I would think. They kind of got rid of most of the ability to smell, so the olfactory area in the back of their brain is kind of gone. So anyway, this beak, which I was going to show you, is made of this keratin-like thing, covered with keratin. And the jaw here now is all these modified bones that are kind of mushed together, so birds can go like this, right? But they typically don't do this like a cow does. It's like up and down, and they gulp their food. They bite and then they swallow down. But it's a very light skull. In fact, I'm going to pass it around. Don't be afraid. It's okay. Okay, so that's a really cool little skull. Now, continuing on, have you guys ever seen a dead dinosaur? I mean, a fossil of a dinosaur at the museum. Usually when they die, the neck curves up like this in kind of an S shape, because all the tendons are pulling on the bones, and they whip their head back like this. And birds kind of die the same way, don't they? You ever see a dead bird? Their head goes back like this, and then they, you know, after they're limp, they get really kind of rigor mortis, and so they're stable. But look at this. You see these bones here? These are all vertebrae here. They're going all the way down, all the way down. There are big vertebrae down here, and this part that we call the pelvic girdle, it's not well developed like a bird's, as you will see. So it's like a chain link fence, right? These are all big vertebrae that go down here. Now look at this. You see these ribs? Touch your ribs for a second. How do yours feel? What shape are they? They're curved. These aren't real curved. These are kind of straight. If you look at lizard, you know, vertebrae, or rather ribs, you'll see that they curve slightly in. Snakes much more so, but most reptiles don't have terribly curved like ours. But these are kind of straight here. And over here, look, this bone, this big bone here. Anybody know what that bone is? Didn't we have that last time with, remember the bone? It's your upper arm bone. Go ahead. Anybody? Did you? Go ahead. Humerus. It's a funny bone, right? No, it's not really. But it's the humerus. And over here, the other bones, remember Professor Krieger was telling you about here? The radius and the ulna. They have them too, because didn't we have an argument about whether they had the same kind of bones that we did? And they do. And over here, though, oh my gosh, look at this. These are your digits, right? And I see 3 long digits here. Look how long that one is. And on the end is this huge claw. Now, when you guys watched Jurassic Park, you saw what kind of dinosaur had these huge claws and it kept going like this, right? At least in the movie. Velociraptor. So these have very big claws up here as well. So what do you think they use those claws for? Go ahead. Catching prey could be, what else?
Climbing.
Maybe climbing, what else?
Go.
Could be snagging something. How about defense? Is that a possibility?
It could be on defense, or if you were young, and like there's 2 possibilities. Like if you were young,
A young bird, a chick.
young bird, and you were in a nest. In that time, you wouldn't want to fall into the ground, so you use your claws to hook onto the branches, and later on, if you only short distance, you can
Right.
hook up.
That's such a good story because there is one bird that I know of. It's called the hoatzin. It's in South America, and it has claws on its wings as a young bird, and then eventually they just kind of deteriorate and fall off. But it hangs on to its nest. And there's some primates down there. Remember we talked about primates, we talked about their evolution, that chase these birds out of their nest. They fall all the way down, apparently, and then they climb back up the tree. And then after they're done getting their feathers and their fledge, they lose those claws. So there is a bird that has claws then, right? But most birds don't. You ever seen a chicken with claws? No. Or a dove or anything like that? No. All right, so we get down to the body here. This pelvis here, you can't see it real well, but it looks like Sue's. Remember dinosaur Sue? It looks just like that in a way. And over here, look at the legs. This big here, this femur over here, and this goes down to a fused part here. And this bone over there, I'll show you in a minute on the other skeleton, is a fused tarsus, metatarsus down here. And then it goes into the digits. And the digits have what on them? Claws. And how many do they have in their back feet? Go ahead, just say. Or don't they have one in the back that, like this? I can't do it with my hand, but they kind of grab on with this. Don't they have these tough tendons that make them grab on automatically? And then you got to pry them loose, which is why, you don't want to be having an eagle on your wrist without a big heavy leather pad there, because it will literally stop your circulation. It squeezes so hard. So look at this tail. And on the tail are all these imprints of feathers. And when I was growing up, they always told me that feathers were the hallmarks of birds. No other creature on the planet had feathers. And then we find something like this 100 and some years ago. And we don't know where to put it, because in the same museum that we have Archaeopteryx, which is the name of this bird, Archaeopteryx lithographica, we also have other skeletons, which are called Dromaeosaurs, that look really similar to this. But they didn't have imprints of feathers. So I was confused, and I thought maybe you could tell me why the other fossils didn't have the imprints of feathers.
Because they didn't develop them yet.
Maybe they didn't develop them, but the rest of the skeleton is pretty much the same. So it didn't what? Maybe it didn't need them? I'm thinking of something even simpler.
They weren't as tightly attached.
Oh, that could be. They could have all fallen off. Maybe they didn't have them.
They were losing feathers like babies.
They could have lost their feathers. Well, I'm thinking this. This fossil, which was made in Bavaria, was covered with really fine silty clays. And so it preserved all the parts of this fossil. Whereas the other ones were preserved in a little rougher stuff. So it didn't preserve all the detail. Isn't that kind of like a camera, a really good camera, takes a picture and you can see every pore on the person's face, versus a camera which is not so good and it's kind of blurry, right? So that's the way fossils are too. This is a particularly sharp one because of where it died. Now in China, there's a province there where now we find these birds and these bird-like creatures, and we find their eggs, and we find all sorts of things there, and they're preserved and we can see the feathers. That's how we know that these guys were dinosaurs. Because don't they have all the features of dinosaurs? What one do they have that says it's a bird, though? Go ahead. The feathers. Okay, well now we're going to go over here to the big guys here. You guys can look at this one while I talk, and I'll bring this one over here. If you guys want to get a little closer, you can do that, if you can see it. All right, so now we started with the head and we went to the tail, right? We know that the tail of that bird has a long tail, like a lizard. Well, let's look at the beak up here. Does this have scales? No. This is your pigeon, by the way. And it's got a funny jaw that's, all the bones are kind of fused down there. This bird-like creature didn't have that. And over here, can you see this ring around the eye? You see that ring? It's a really hard, bony ring, and that makes the eye kind of long. So they have really good vision because that whole eye is stuck out a bit more. It makes it better vision. So that a hawk or an eagle can see maybe 8 times as good as you can, which is why they can fly way up there and they can see a little tiny mouse in the, in the field or something, and they can nail it. Now look at these vertebrae here. You see these right here? What shape is that? What's the letter? It's kind of like an S, right? Similar to that one over here. And back here, you can't see these too well. These are your scapula, very good. And they're very narrow on this bird. And then down here, right there, what would those be? Your collarbones, your clavicles, and they're fused together. They're called the Percula. So here is a bird. Look, now here's the mechanical part. This joins to this big bone here. Does anybody know what this big bone here is? Not quite. The sternum. All right, just for a second here, let's look at Mr. Ed over here. You see here sternum? That's you. Do you have a big keel on your sternum like a boat? You don't. So what do you think is attached to this keel right here? What do you think? Yeah, when you have Turkey Day, you have your bird like this, right? And then you cut the meat off right there, don't you? And that big bone is sticking up. That's the thing you put in the refrigerator later on. The wing muscles. What kind of muscles do you think you'd call them? If you called these your pectorals, pectoralis, do you think you'd call those the same? Yeah. So they have pectoralis major and pectoralis minor, but I like my students to learn supracoracoideus. Might have even told you this muscle before. But it's because it goes over a certain bone here, and this is the bone right there. You see this coracoid? That's a big bone, isn't it? Now, who's the mechanical engineer here? Anybody? If you want to make something strong and you want to make it so you can't break it, you can have multiple attachments, right? You see the furcula here going down to the front of the sternum, and over here you have the coracoid going to the back of the sternum, and then underneath here, what do you have attached to it? This is all lightweight, right? It kind of makes a box, doesn't it? So in here are all the insides, really, all the organs, correct? In here, that's where your body weight is. So who wants to stand up and show me how you would stand as a bird? You want to show me? Good. So all your organs are going to be kind of in a line going right down the middle, and you're going to be kind of thrown this way like you do in yoga, right? Well, they're like that all the time. So if you're scraping the ground like this, you got to keep your balance. Well, you don't have that long tail anymore, do you? Because what happened to the tail? The pigeon style, what happened to it? Yeah, it's small now, right? It's very small. And look at this part here, this expanded part of the vertebrae back here and part of the pelvis. Is yours like that? Back here you have kind of a sacrum back here, but this is big, isn't it? So we have a box up here and we have a box down there. What do you think that does to a bird that's flying? It balances it, right? What does a bird do when it flies? It does flap its wings, but doesn't it tuck its legs under or back like that? You know, there's a pose for that one too, isn't there? So yeah, it puts the legs back, but you get that balance right there, correct? Does this thing have that kind of balance?
No.
Why not? Well, look at the vertebrae over here. It's like a chain link fence, like I said. But this thing is all fused together. It's rock solid. So when you're flying, your tail isn't going like this all over. It's straight. Remember the frog skeleton? It's reinforced in the back. When a frog jumps at something, it goes like this. It doesn't go like this, right? This does that too, but it's got to fly. Now there's one really cool thing about the ribs here, and I don't know if you can see it. On that one maybe. You see it looks like a little tab. It's called the uncinate process. It goes over the other ribs there. Can you see it? So when you bring your muscles down, everybody goes down together. Why is that important?
So one wing's not up and the other wing's down.
And you're contracting everything together, right? You need a lot of power if you're going to fly. Could this thing fly?
Not very loud.
Why? Now you saw a keel here. Is there a keel in this bird? Not really. So birds that don't have keels, or maybe they lost their keel secondarily, really don't fly very well. Because what are they missing? They can't attach what to the keel? The what? The muscles. And what do we call those muscles again? Pectoralis, right? Pectoralis, pecs. You call them pecs. All right, now, this thing is a very highly modified dinosaur then, isn't it? I mean, let's look at it. Horny beak, no scales, no teeth, right? Although there's a guy up in Toronto, I think, that's trying to make chickens have teeth again. And we have a sclerotic ring for the eye. It supports the eye because birds don't go like this. They go like this, right? You ever see that? Birds look at you directly. They go like this. You know, they're shifting their little eyes around. So they look kind of beady in a way. And then over here we have an S-shaped, you know, neck vertebrae. And then this is really solid here, and it's really solid there. Short tail, not like this guy over here. Look how long that tail is. That's a dinosaur basically, isn't it? So all these things taken together, even down here where these are fused bones of like the ankle part, because the big bones of our legs are up here, right? And down here, this is fused together. These are not quite fused in this animal down here. But it looks a lot like it, doesn't it? Wouldn't you say? But there's at least 15, 16 things minimum that are different about this. And you know what they look like? They look like Sue, don't they? They even have a wrist bone here, which it's a lunate bone that allows you to turn your wrist. So you guys turn your wrist, okay? All right, now I want everybody to try to fly. And I want you to, okay, how is it? Is it hard? That's like an albatross there, you know? It's like one flap and you're gliding. Okay, so, okay, keep going, keep going. You guys are tired already? Don't you want to contract it this way? You don't want to go like this, do you? Don't you want to go like this? Try that. Is that working? Well, here's the problem. You got to get your body off the ground, don't you? I didn't see anybody get off the ground here. I just saw everyone stayed in their chair. What kind of power output is that? That's not very good, is it? So,
Velociraptors have the same wrist bone.
yeah.
Velociraptors, they've got that.
Yeah, the lunate bone, they can actually move the wrist. And maybe that was for capturing prey, like snap up there and I can twist you and I can put you up there and eat you, right? I can snag you with my claws, move my wrist. I mean, that's pretty handy, isn't it? You're not just like this now. So you got to turn to capture something. You can capture something on the fly, like, you know, a catcher out there and, you know, right? So isn't that kind of cool? All right, so birds are really special dinosaurs then, right? Here's what I think we should call them. I think we should make their own group. I think I've told you guys this before, but I think we should call them Dinosauria. Dinosauria because the lineage, the group that gave rise to birds, is somewhere in those dinosaurs, right? Now, do you think there are weird kinds of birds outside of Archaeopteryx? I wouldn't even call this a bird, actually. Most people do, but I don't. Because I'm thinking it's got all the dinosaur features, and even the one that we thought was bird is found in dinosaurs now. So why would you call that a bird? Makes no sense, does it? Not to me, anyway. Well, there were birds, quote birds, or bird-like creatures, that also had feathers on their hind legs. So when, I can't do this because I'd have to be off the ground, but imagine, you've got wings up here and you've got wings down there. You're like a biplane. So you can fly, but those didn't make it through, did they? For whatever reason, you don't have birds out there today with, that I know of, that wings on arms and legs, right? Okay. So does that make sense? Is that good? All right. So we solved one problem maybe. We're going to maybe, because I've kind of biased you, we're going to call this a transitional group. It gets its own name because it's not really, not this thing here, this thing over here. This is a bird, right? This is what we call a bird. And all modern birds have virtually the same features, as we'll find out. But Archaeopteryx and the ones like this, like Caudipteryx was another one, and Protarchaeopteryx was another that came before it, they're not birds. This is a group of bird-like creatures. If we put a box around it, we can call it anything you want. You guys want to make up a name? What do you want to call it? Birds to be? How about that? Birds to be? Wannabes? Bird wannabes? To be? Okay, birds to be. And they're not birds, and they're not dinosaurs. They're in the middle. This gives you a good idea of what really happens when you have evolution going on, right? You don't have the same things because once you get to a certain stage, they're going to be different. So that thing is unique, right? And that thing is unique. And so are you. But do you have similar bones like Professor Krieger pointed out a couple weeks ago? They're very similar. You've got ribs, you've got a sternum, you've got femur, you've got tibia tarsus, you've got all those same bones. So that tells you that somewhere along the way, you have lizard-like creatures going this way, and you have mammal-like creatures going this way, right? Because we have, yeah. So it fits, but we're all called, believe it or not, we're called amniotes because we have a certain kind of membranes that we form. Now, you guys were formed in an amniotic sac. Does anybody know what their sac look like? It's the water sac. These guys have a water sac in their eggs. So when you crack a hard-boiled egg, you'll find part of those membranes, the egg membranes around it. And if you have a fertile egg, you can see them. Yeah, yeah, that's exactly right. So birds are kind of intricate, right? They're very unique, but even penguins have feathers. So we have some feathers here I want to show you. And maybe you guys can tell me what you think feathers have come from. Go ahead. Yeah, anybody?
Scales?
Yeah. Now, why do you say scale? Just because I told you? So why?
Because they're overlapping in the way the scales would.
Okay, they're overlapping, and they actually, if you look at how they develop just like scales. They start on your epidermis, and they kind of sink down, and now capillary, a couple of vessels go up to feed them, right? They take blood to them and take blood away. So if you break off what we call a big primary feather, one of these big ones that's part of the wing here, they can bleed, right, if you pull one out. Does anybody have a parrot or anything? You pop one of those out and they can bleed, and sometimes you got to cauterize it, you got to plug it up. So you don't want those to bleed too often. Now the rest of the feather is dead, right? But there's different kinds of feathers. These are the ones that form the wing, the vein of the wing, they're outside my arm, literally. And there's other secondaries and tertiaries. But on the body, we will have softer feathers, down feathers, kind of like the hair on the back of your neck is real soft, They call it the angel hair, don't they? Well, you've got little fuzzy feathers, too. They're made of the same protein. Does anybody remember what the protein is? Starts with a K. Very close. Keratin. And we all have it, fingernails and hair and this, but these are a little bit different than our hair. So the group that went to become mammals still uses keratin, but the group that became dinosaurs and birds and everybody else with scales and feathers gets their keratin in a slightly different way. So feathers kind of make what we call birds today, right? All right, now some of these feathers are really pretty, aren't they? And others are just not very pretty. They're just kind of brown. Does anybody know why there's different colors? Now, you got to think back way to Professor Niles, Dr. Tom. He showed you colors, remember? Oh, yeah. So, from a, what kind of bird? Peacock. Peacock? In Grand Rapids? No. Why not? They have peacocks in Grand Rapids. They have one at the zoo. I saw it, or they used to. I don't know if it's still there. But I know people who have peacocks. But look at this feather. This does not look like this feather, does it? This feather is different than this feather, but they both have a quill down here that if you break off, this one was actually broken off and somebody actually wrote with this one. You can dip it in the ink and it sucks up ink with capillary action and you can write your name, you know, Matt Douglas or whatever. This is what they used to use. And this long part here is also made of keratin. It's flexible, but it's very strong. So some of these feathers are feet long. They're huge and therefore display, right? If I want to attract a female, I'll go, hey, look at this. Look at my eye spots. Would you guys be attracted or? No, not really, because, you know, you don't really care for feathers that much, right? But if I have a feather like this, look. This feather has the same rachis, or this central part here. It's hollow. But it also has these. Now watch, here's what I'm going to do. I'm going to take it apart. Now if I do that, doesn't it look a little bit like this one? Right? All right, so mostly birds are doing this. Aren't they going way back because they have a very flexible neck? And aren't they doing this with their beaks, you know? They poke at their little tails back there. They have a gland right back here where they pick up oil, and then they spread this on their veins like this to get them soft. Now, there's something weird about this feather. Archaeopteryx, this bird-like creature, we put in a different box now, had feathers that had this central shaft going right down the middle. And this is a modern feather, and you can see the shaft doesn't go down the middle, right? So why? Help me out here.
The feather evolved so that
the shaft here?
The shaft might not get, which less likely to get damaged because someone will go for the feathers.
Okay, that's possible.
Since they couldn't fly, maybe it would have something to do with aerodynamics.
Oh, that could be. It's very good. So, go ahead.
If they wanted to fly, maybe it would help them fly one way, like, because no bird that I see can fly backwards.
Okay. Now, here's the thing. If I'm flying and I have this feather like this, and I'm going into the wind, what part takes the brunt of the wind? Isn't it this part right here, this front part? The leading edge, tell me, is that stronger than the vein part? Yeah. So that is aerodynamic, isn't it? And you strengthen this by putting this up in the front instead of having it down the middle. So when you talk about Archaeopteryx, could it fly? Well, it doesn't have a keel. It doesn't have very big chest muscles. You guys got tired just trying to fly in your chairs. Can you imagine what it was like for that thing to fly? Maybe it ran really well and it hopped up and it had some aerodynamic stuff where it could fly. Or maybe it flew down from low branches to another branch to escape enemies. Like turkeys. Only turkeys have huge chests, right? They're enormous. And by the way, domestic turkeys aren't representatives of our wild turkeys because they develop those just so they have a huge chest. Sometimes it's like they fall over. And if you go to Zeeland, Michigan over here, in thunderstorms, they all crowd together under a tree and they kind of suffocate. So they're not known for their brilliance. But anyway, you guys wouldn't do that, would you? But I have friends who rear turkeys, and that's what they say. They're just a thunderstorm, and they'll lose turkeys all over the place if they're out in the field. Anyway, I don't know if those are old husband stories or what. So this thing is aerodynamically well. But look, isn't it curved? Okay, so let me show you a wing. This is kind of gross, but here's a wing from a bird. Okay, here's your humerus up here and the angle over here, and these are all your little phalanges with feathers on them. And here's a little bone up here. It's the second digit of your hand because these other ones are going back, right? These are fused. They argue over which ones are fused, but here's the second one. It's called the alula. That's a brake. You guys ever flown in an airplane? Okay, when they're starting to land, you hear that whoosh. What's that? They go up on the wings, right? Well, this thing, you can adjust your digit like this to, fly better. But there's birds like hummingbirds that don't do that because they don't need it. Tell me why they don't need it. Hummingbirds. They don't need a well-developed wingtip like this. Why not?
Because they can
They can
hover.
hover, right? And sometimes they're going like 80 beats a second, I think it is. It's really fast. And their hearts are going really fast too, right? Yeah, it's like that. Do that for a while. It's hard, isn't it? So I'm going to pass this around. You can see the primary feathers here and the secondaries, and you can even see some of the contour feathers which give it shape. Now why, here I'll let you pass it around. Now why, or I should ask you, what is the shape of a bird's body? Is it square? Is it long? What is it? Kind of bullet shaped. So even penguins are kind of bullet shaped, aren't they? And they don't even fly, do they? Do penguins fly? No. Yeah, they do. Where do they fly? In the water, don't they? So their feathers are shorter, their bones are much stronger, and it looks like a flipper now, right? But it's a wing, isn't it? Is it hard to fly in the water? They go pretty fast, don't they? Yeah, and they're very buoyant because they have light bones as well. So feathers have different colors. We didn't answer the question. This is one of those iridescent colors. It'll change depending on the direction sometimes from blue to green. So that's from the light hits it at a strange angle and it's kind of reinforced and you get those colors. Other ones like blue jays, I think I've got a blue jay over there, are blue no matter which way you look at them. And that's caused by a different phenomenon like scattering of light. And underneath that usually is a dark pigment called melanin. So when you look at a blue jay, it's blue, right? And some of the blue jays out west are really blue. So there's pigments. Why do they want the pigments? What do they use those for? Go ahead. No, you go ahead. Pigments? For mating is a good idea because females can see bright colors. And a lot of birds have these fantastic colors, and the males do, what do they do with these colors? And sometimes males will say, hey, this is my territory. I'll beat you up if you stay here, right? Isn't that right?
Warning calls of danger like white-tailed deers.
Kind of like that. Sometimes birds fly in a flock, like scarlet macaws will take off, and then the rest of the flock takes off too. So colors do a lot, don't they? You can attract mates. You can scare away the same sex like males, right? Or you can be camouflaged if you're a female because you don't want to be too gaudy. So don't you think males are taking a chance when they're showing their huge peacock feathers or the grouse is up there thumping on the ground, etc.? Don't you?
It's like saying, hey, eat me.
Yeah, right. So males, I don't know. I think they should change their game plan, don't you guys? Maybe we should get a little duller so we don't show ourselves too well. You guys ever see birds fly into windows? Sometimes, what do they see? They see the reflection, and sometimes the males will go after it. But in other windows, it looks like it's clear space, especially at night when birds are migrating through, and they hit those windows, and then that's pretty much it for them. So we have snipes out here often. We don't find them in Grand Rapids, but they're coming through, And other songbirds, even eagles and hawks once in a while will hit a window. Yeah, and when they hit it, what happens to their neck? Because they have a lot more vertebra than you do. 13 to maybe 20, and you guys only have 7, right? And they can turn their necks all the way around, can't they, like that? Can you guys do that? How far can you get? Maybe 180 degrees, right? Okay. So you got a torpedo-like body, like a bullet. Is that good for airflow? Yes. So you have a torpedo going through the air, and you've got these, where's my wing? I lost my wing. Is it still going around? Oh, that's okay. We've got these feathers that have this camber to them, right? This curve. And the wing has a curve. And the pressure underneath is going to be a little higher because the wind's got to flow a little faster over here. But then they also make these currents. Do you ever take something in the water and just stir it along? It makes eddy currents. They call them eddies. And those eddies give you some lift. So if a bird's flying like this, tell me. Bird's flying like this. Okay, once in a while I'll beat my wings, right? Or maybe if I'm hovering, I go like this, back and forth, because I've got my bones I can twist, don't I? And my wrists, I can twist them to steer, you know, like that. It's very complicated. Do I want to be an autonomic, do I want it to be automatic, or do I want to think about it? Should I turn my wrist, or? Automatic. I want it automatic, right? So the part of your brain that's well developed is your cerebellum back here, right? Your cerebrum, not too much, although there are some very intelligent birds. So if you're flying like this, does it cost a lot of energy to fly? Oh, it does, doesn't it? Because you guys couldn't even get off the ground. So what kind of lungs should you have? I mean, my lungs, I breathe in. They go through little air sacs. I have a thin membrane down there, and my oxygen kind of diffuses out, and the carbon dioxide diffuses in. But I got some residual air, some air that never leaves. But how about birds? You guys know what, somebody said it. Somebody said air sacs. Did you say that? Okay. So go ahead.
But I have a guess. You need like maybe a third lung to save a lot of air. So like you get into high pressure places, you can still breathe.
Right, and birds are famous long distance flyers, right? Some of them, I mean, like these terns, these Arctic terns go up almost 11,000 miles in this crazy arc. And then they come back. That takes a lot of energy, doesn't it? So they don't have a lot of fat, you know, until they're migrating. They don't really mold their feathers usually until after they're done with the child rearing, so to speak. And then they got to get up and go. Now tell me, why do almost half of the birds migrate from Grand Rapids and go all the way down to the Bahamas? Why do they do that? Is there a vacation package down there?
They can't generate as well in winter.
They can't stand the winter? But I like winter up here. I go skiing and stuff like that. It's not that bad. And they have feathers.
Food sources are gone.
Food sources are gone, exactly. Because in the fall you see all these birds like, you know, buntings and robins and things like that, cleaning up your yard of berries and whatever else. And then they're out of there. And you're right, they go to someplace that's warmer. Well, if you're someplace warmer, does it cost less energy to stay warm? Because birds have really high body temperatures. You guys do too, but they beat you by quite a bit. And they have those air sacs you were talking about. So when you breathe in air, it goes to these air sacs in the back. And then it goes back up to the lungs and then the air sacs in the front. So you need 2 ventilations. You got to go as a bird to get all the air cleared out, but it's a one-way flow. And you guys do what? You go, and then you leave some air in there. And that air is kind of, it's not stale, but it kind of is. You don't flush it all out. Birds can flush it all out, so that's pretty good too. How about their heart? I got a heart here. You want to see it? That is from a pigeon. Look how big that heart is. Isn't that huge? Yeah. How big is your heart? Show me. About the size of a fist. And that heart, proportionally speaking, is not anywhere near yours. It's much bigger. So why would you want a big heart?
Again, but they beat faster too. They keep up.
They beat much faster, sometimes hundreds of beats per minute. Very fast. Hummingbirds, you can't even hear it beat. It goes, it sounds like a buzz. Do you guys know there's a hummingbird called the zunzun in Cuba? Do you know how big it is? Have you ever seen this? They call it zunzunito, I think, or zunzuncito. It's as big as a bee. Now, how big a nest does it have? Can you imagine seeing one of those? Wouldn't they be? Yeah. Yeah. Tiny, and you're right. It's as big as a large bee. It's crazy, isn't it? Does it lose heat fast, though, because it's very small? So would you find them up here? No, you're going to find them where it's nice and warm, a lot of sunshine, you know.
How about an acorn cap?
What's that?
How about an acorn cap?
Yeah, you could do that and it would make a nest out of it. So they use spider silk and stuff like that to make their nests. It's really kind of cute. So that is a heart. Now, does anybody know anything about our heart? Anybody? Okay, when you look at your heart, don't you have a huge arch that comes out this way? Yes. The left side, right? The left side, and the right side is much smaller. It goes to the arm over here. But look at that heart. Tell me, what side is the biggest side there, if you can see it? It's the other side, isn't it? The right side is the bigger side.
The right wing.
And we kind of like that, and it's more symmetrical. Ours is really asymmetrical. We have this huge aortic arch there, and they have two, but the right side prevails. Now, if you're flying, you don't want too much weight, right? So what are you going to reduce? You're going to, you guys said it, you have air sacs, you have bones, you have,
That's why they poo every time they're going to take off.
they do that. Now, tell me why they do that. They lose more weight, and they don't have a bladder. So, you know. Well, you think about it. A bladder stores lots of liquid, right? Did you ever lift up a gallon of milk? How much does it weigh? That's like 7, 8 pounds, isn't it? Something like that. I'm probably wrong, but something like that. It's pretty heavy. Well, if you have a full bladder and you're flying, it kind of works against your pectoralis muscles, right? So we have a lot of adaptations for flight. We have lift. Here's the question for you. What if I'm a smart young bird and I think I can take off faster than any other bird? And instead of listening to my mom, and she says, go straight like this and go up easy, everything in moderation, and I say, oh, Mom, I can do this, and I try to go straight up, what happens? Why? Those are very good sound effects. Why do you go like that? What do you lose? Well, yes. You lose energy.
And the wind turns, usually it doesn't go straight up.
Right.
It goes across.
So there's a name for this. Anybody know what it is? When you lift yourself up, we call it lift. It's called lift, right? So when you fly, you don't want to lose lift in an airplane. You don't want airplanes going like a rocket, right? You want airplanes going up at like this angle, and then you want them to level off, right? Well, if you go up too fast, you stall. And you go down. Birds might have a chance because they can stall on demand. They can stall and then fall down, and then they can pick up their wings again. But it's harder because you're going down pretty fast. Gravity loves you, right? Pulling you down. All right. Here, I'm going to pass this duck skull around. Here's another thing. Here, I'll just pass it to you. They've got very lightweight bones, and they've got other things. So you got a heart. I had a couple other things I want to write down. The brain is smaller, and the cerebrum is smaller. The blood, you guys, do you think they have high blood pressure or low? No. They have really high pressure, right? Because they're servicing the whole body and quickly. The lungs, you guys got the lungs. Digestive system is all compact, you know. They have a gizzard, right? You guys ever eat gizzards? You don't like them? Gizzards are good. They call them organ meats, I think. I don't know if you can still buy them in the supermarket. But if you made chicken noodle soup, if you're certain parts of Europe, you cook the whole carcass, you get the broth, and then you have the gizzards, the liver, you know. What else? Yeah, hearts. High protein meal. You cut them little pieces and you put in there. No one knows the difference. You say, is this soup good? They go, oh, this is great soup. And then you say there's gizzards in there, which are a real tough stomach part, you know, and livers. And they go, oh, right? So if you eat it and it's good, I would just say, oh, that's really good. I really like it. All right, now, do chicks hatch out always perfect?
No.
Why not? I thought the world was perfect. It's not a perfect world? Well, here, I'm going to pass around some chicks. Here's one with a bad beak. You can pass it around. It's got a cross beak. That's actually a mutation. And over here, here's one that formed its brain outside its skull. And here's one with the external intestines and a brain. It's kind of gross, but yeah, there's lots of chicks that are born like that. They're not all born perfect. Those chicks won't make it, so usually the development just stops. Okay. Now we talked about gizzards. In here are gizzard stones. You can't eat these. These are from a dove. They grind up food in their gizzard there, and these are some of the stones. You can pass those around. And then I'm going to pull out my favorite. Wilma, you know about these, don't you? Pellets, owl pellets. So I'll pass a couple of these around. They smell like a little bit like mothballs, but they're okay. Here, have one. You'll see little bones in there. You can tell me what you think they eat. Look at that one. Looks like an egg. Do you want to touch it or no? No? Okay. You don't have to. You don't have to. A nail? You mean like a fingernail? You mean like a real nail? Maybe. Do you guys want to see more of these? You can actually, here, I'll throw you one. You ready? Oh! You want to see one? Look at the size of that one. That was a big, oh, that's got some crystals on it. I think you want that one. It smells like mothballs. You're not supposed to breathe this stuff anymore. Naphthalene is nasty stuff. Yeah, I know. They're old. Like I said, they're old. Do you guys know what pigeons are? You ever seen pigeons in Grand Rapids? Downtown? All right, well, this is the skeleton of a pigeon. Do you guys like pigeons?
Yeah.
They're really
Food for other animals.
it's like opossums and raccoons and stuff.
What's that on my
And you see those birds up there, like the kestrels and the owls and the falcon, they eat pigeons. They will eat pigeons. Now, does anybody know anything weird about pigeons, how they drink water? Most birds have to drink and then swallow like this, but pigeons can stay down all the time. Is that a nail? That looks like a stick. Well, I can give some of these to you. You can take them back.
Yes.
Sure. They're sterile.
Which one has the
External. Outside.
external
Yep.
insides?
What was that?
Which one has the external intestine?
I think that one, or
This guy
maybe
has
it's over
external
here.
intestines.
There you go. External intestines over here.
This has both of them.
Here's the external brain. Has everyone seen that one? That's kind of a neat one.
Oh, where's the external? See, they all have external brains. I know.
So that must be a pretty common defect, right? When you don't grow your skull bones over your brain. Doesn't work real well.
And two of them have intestines coming out their butts.
Right. We call it external. Same thing, though.
Griffin likes that stuff.
Does he?
This one has it too.
What?
Look.
The external part? Well, that's kind of development. Remember we talked about development? Do you guys remember the video or the DVD I showed you last time with the developmental genes called Hox genes and things like that? Those are patterning genes, and sometimes when there's a mistake in those genes, that's what you get. You get organs on the wrong side of the body.
I went to Ripley's, believe it or not, and it was this one. It was actually, I think, a hen with 4 legs.
Right. And sometimes the embryos fuse together. But I have a question for you. These pigeons right here, I was going to dissect them, but I figured maybe you guys don't want to do that today. Well, I can do that a little bit later because we're running out of time. I really have to get to this table over here because I want you guys to pair off into teams. But I wanted to tell you when I was at the Field Museum, or the Shed Aquarium. Anybody been to the Shed Aquarium?
I have.
Okay. Well, in the windowsills, because these rock doves, these pigeons, like to nest in there, they put these little sharp stakes of plastic. And you know what I saw in there? I saw a nest on top of the plastic. So you know what they did next? They had to screen off all this area because they don't want pigeons there because they tend to make acid when they, you know, defecate, and it tends to ruin the marble and stuff.
Little birds can like make nests in tubes because they don't need that much.
Right, right. Now, I'm kind of rushing through things here, but I have a table here. And I wanted to split the class up into two groups. Maybe like right down here. How's that? How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7. I'll have you go over on this side. And here's what you're going to do. You're going to look at these birds. Now you know some of them, and you're just trying to learn the common names, okay? There's like 12. Yeah, they do. But you're going to try to memorize them, and then I'm going to hold them up and say, what's this bird? But there's something else I want you to do. I want you to look at the beak and say, what does that thing feed on? And then I want you to look at the feet and say,
Maybe write them down.
yeah, you can do that. Is that a perching bird? And I'm going to quiz you guys, and we'll see who knows these birds the best. So why don't you go over here, and then you guys come over here, come over to this table, and we'll try to learn these. Now, like I said, you know some of these birds, right? Like this one.
Crow.
This one is called crow on a stick, because there's a stick right there.
Barbecued crow.
Barbecue
That's so
crow.
black.
Right? And notice that these are very light, right?
Are we allowed to
Because they have no innards.
You can pick them up.
No innards.
Right, they're very light,
No innards.
and the feathers weigh more than the bones.
This guy's got a poofy jaw.
Yeah, so what's the name of that one?
There's a gull.
Okay, what's the name of this one?
That's a robin.
This is an
Robin.
This is an Oriole.
Oriole. Is that the Oriole or the northern Oriole?
This is a
Okay. What's this one? This is one of my favorite birds.
chickadee.
So what does a chickadee say?
Chickadee.
Yeah, that's it. Very good. So it doesn't even have a name because I figured everyone would know it, right?
Red-tailed hawk.
Cardinal. How do you know it's a red-tailed hawk?
It's got
Has
red
red
tail.
Okay, show them the red tail. Okay, wait this way. We'll show them the, show them the red tail. So Cooper's hawk, I have one of those in my backyard.
Oh yeah, you're right.
This guy's the other.
Sweet bird. It stands over my ponds now, looks at my fish. Doesn't do much.
I like his beak.
Bluebird.
This one's foot.
Is that a bluebird or is that a
I mean, not a bluebird. It's a
blue
jay.
jay? Okay.
This is yeah.
Oh, well, it happens.
Definitely a robin.
The foot, it happens, you guys. It's okay.
So nasty.
Indigo bunting, I like that one.
Man, look at
And the cardinal, this is a strange bird because its name is Cardinalis cardinalis, our cardinal bird. Yeah, sure.
Is this a female because it's lighter?
No, that's a male.
That's a male. And what does the female look like?
What's this one? What kind of goose? You guys saw that at the John Ball Zoo. What kind of goose? Is that what the tag says? I think it says something else.
Canadia.
No.
Brontis canadensis.
Yeah, but it says Canada goose, right?
Yeah.
Canada goose. What kind of owl is that? Is that an owl?
Oh yeah.
Great horned owl? Why do they call it a great horned owl?
It's got a really big hole.
It's got horns. Good. Okay. What's this one over here with the red head?
Some kind of
It's a woodpecker.
What kind?
Red-headed.
Oh, red-headed. So,
I was saying it while I was looking,
okay.
but I did not see it.
So red-headed woodpecker.
Oh, look at that. Look at that.
What's this one right here, you guys?
Cedar wax.
Cedar waxwing. Isn't that a pretty bird? Look at the tip of the tails.
Dr. Matt.
They come through in flocks in the late summer, early fall,
Dr. Matt.
and they eat all the berries.
When they're flying, they're like it's the whole entire back is
Yeah, right. And they invade your yard, maybe 60 of them, and then they fly off and invade the next yard. Yeah.
This guy's got little teeth like
Yeah, yeah. These are not the same kind of teeth as the ones up there, but these are made of keratin there.
As a baby, they do have teeth. They're egg tooth.
They have some, yeah, they do.
this guy has little teethy things. And feel his neck feathers.
What is this bird? Looks like everybody knows. Go ahead, anybody. Red-headed woodpecker. Why do they call it a red-headed woodpecker? Oh, this is a male or female?
Male.
And what kind of feet do they have? Did anybody look at the feet?
Grab it.
Yeah, because they're kind of like this on the side of the tree. What are they looking for?
Termites.
Well, grubs or beetles and things like that. How do they find them?
They go peck.
Well, how do they find them?
They dig up the vibration.
With their tongue.
The vibrations and the movement, they
That's what
can
robins do.
they can hear. Do these guys have ears like you do?
No.
They don't have a little.
Let's
They don't have that, just a hole in the side of the head?
Yeah.
You think they hear pretty well?
Yeah.
You ever see a woodpecker
Yeah.
in a tree listening? And then they go like this, right? Okay, well, doesn't it hurt the brain?
Yeah. No.
Not a woodpecker.
Shock absorbers.
They have like a shock absorbing skull, and they have a very long tongue that goes way back here. So it's really kind of cool because then they can pull the grubs out when they do that. Okay, this one.
Mallow duck.
Wow, you guys are, this is like 100% for the whole class. So what about this bird? What kind of feet?
Web.
Web for
Swimming.
swimming. And are they kind of far behind, do you think?
Yeah.
So they're way off, aren't they? I mean, you know, do they have a hard time walking on land?
Yeah.
They're not real graceful, are they? They waddle.
Waddle.
And what kind of a bill?
Slurping.
Now these are serrated teeth here, but of keratin, not enamel, not like yours. So what do these guys feed on?
Water.
Plants.
And debris at the bottom, insects, whatever they can screen up, and they screen it. You guys have seen them, they just bobble down and they bobble up. Right. All right, how about this one?
Crow.
Crow on a stick, yes. And what kind of a beak? It's a scientific name.
Hook. No. Stabbing.
Not really hooked.
More or less like
What does this crow eat?
Bugs.
dead animals.
It eats
Scavengers.
anything it wants, right? So you can kind of tell by the beak there, they can be pretty vicious, you know? Yeah. So look at the feet down here.
Nasty claw.
Yeah, they're kind of perching, grabbing type beaks, but crows are smart, aren't they?
Oh yeah.
You know the bird of paradise that's in the same family as this. And they're very pretty and they're very smart. The males put on these incredible displays, you know, for the females. And then the females saying, no, I'm not interested, and so see you later. You know, so typical. How about this?
Great horned owl.
I thought he lost something. It was just a paper towel. Okay, great. Why do they call him a great horned owl?
Big horned ears.
Okay. So what's this all about here?
Beak.
And
So trying to open.
pretty good vision. Can they hear pretty well?
Yes.
So do they turn their eyes like that, or do they turn their whole head? Because their eyes kind of stationary. When the birds are flying, they have a membrane that goes over there to protect their eye, you know? Because you're going at 60 miles an hour, you get bugs, you know?
Yeah.
So protects them a bit. So that's good. Okay, how about this one?
Seagull.
Why are seagulls in Michigan?
Because of the Great Lakes.
Oh, and there's water here, right? We have like 25% of all the fresh water in the world. We should protect that, right?
Yep.
This past weekend I saw Asian carp at the Shed Museum in an exhibit. There's 4 species actually there. And they have their eyes almost on the bottom of their heads because they feed on the bottom. But they're very active fish. In fact, we could throw fish food in there and they'd go crazy in this tank. So they got this 10-foot wall so they can't jump over the shed there. How about this?
Red-tailed hawk.
You see any of these over the expressway?
Yeah.
What are they doing?
Looking for rabbits.
And whatever else, look at the beak.
Nice hook.
Hooked.
Hook.
A good thing to rip out.
Flashlights.
Yeah.
Eyeballs.
And how about the feet here?
Talons.
Talons. Doesn't that look like Deinonychus or Deinonychus?
Deinonychus.
Yeah.
Or Velociraptor. Yeah.
You like those? So these are pretty nasty, right? And they're well shaped. How about this one?
Cardinal.
Cardinal.
Male.
Male. Does this one like this one?
Yes.
Will it eat it?
Yes.
If you get a chance, yeah, well, these things will eat just about anything. But these are more like a Cooper's hawk. You know, oh, sorry, I wasn't supposed to give you that. Cooper's hawk, okay. These will eat, you know, anything they can find. Chipmunks, you know, birds and babies, right. So, okay. All right, now this one over here, one of my favorite because it's your friend for the whole, and very good. And what do they eat? Seeds mostly. So they're a favorite, bird feeding. At a bird feeder, they're a favorite bird, right? And you can actually train these to come right to your finger. I have some that come right to my shoulder. Did you do that? They'll eat out of your hands. And they're so cute and they're kind of fearless. And they're one of the few birds that's really common.
Atlanta scared it away. She thought it was attacking me.
How about, really?
Blue jay on a stick.
Blue jay on a stick. Okay, so what kind of a beak does this have?
Pointy.
Does it look similar to this beak?
Yeah.
Okay, so a related bird, right? What does this thing eat?
Anything.
Anything it can, exactly. They can be pretty vicious too. How about this cutie?
Cedar waxwing.
Cedar waxwing with a pretty little tail over here and perching legs and a beak that looks like it's for
Cracking nuts.
berries, nuts, seeds, typical songbird type thing. Oh, this one. Canada goose.
On a stick.
Now remember what the one was doing at the John Ball Zoo. What was it doing? You guys got too close? How did it do that? That's good. Did it lower its whole neck and head though and kind of go after you like a snake? Didn't it look kind of like a snake? Yeah, you don't mess with those. And here, American robin. Why did you say American robin?
They live in America.
Yes, and there's also European robin.
And they don't migrate. Yes, they do.
Right. Well, sometimes they do. And some. No, you're right. I have robins all year round because I have fairly warm water, and if it's a mild winter, they don't. Other years that they will. So, in really bad years, look at this beak here. What does this thing feed on? Well, worms, grubs, whatever they can find in the dirt. How do they find them? No, they turn their head like this, and then they turn their head like this, and then they watch and they drill in, right? But on really bad winter days, these guys will eat anything you put out. I remember probably 15 years ago, there was a terrible ice storm, and we had sheets of ice everywhere. And they will eat suet, they will eat seeds. I had dozens of robins around, bird food that normally they wouldn't eat. But when they're desperate, they'll eat, anything that you put out there. So these are all kind of neat birds. Did we do this one?
Northern
Oriole.
Which means there must be another kind of Oriole.
Southern Oriole.
So these are pretty birds. A lot of these birds are declining though, even the common ones, except the chickadee. I still have a lot of chickadees. Right, and I still have some good hawks and stuff. Is that all that I gave you?
You forgot that.
Oh yeah. This is a cutie too, right?
Indigo.
And what kind of bill is that one?
Seeds.
Seeds maybe. A lot of these guys, you look in the bird books and they'll say eat seeds, but then you see them eating insects and worms and stuff. You think, wait a minute, that's not listed. The thing is, just like our lizards over here, they will eat anything that's available, if it's available. And it looks like you can eat it.
If it's edible, they eat it. Yep.
But their beaks are kind of adapted to maybe seed eating or predatory or whatever. But a lot of these birds will change their diet if they have to. You don't want to be left out. All right, so you guys have done really, really good today, right? You guys know, how many birds do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 birds you know by sight. Now I have one question before we go. You gave me all common names. Shouldn't we know scientific names too? Why not? Like, shouldn't we know Budio or Cardinalis?
And if we say it, nobody else will know about it. No.
Well, in most zoology, we need to have that nomenclature like Homo sapiens, Danius plexippus. Why don't we often do that for birds?
Because people ask what we're saying.
Well, I think this is kind of true. I could be lying, but most birds have a common name that's virtually not used anywhere else. So when they say American robin, it's different than the robin in Europe. Otherwise, they would just say robin. The regular robin is over in Europe, and our American robin is not a related bird. So common names are at work for birds. Now, I'm not a birder, but we do the same thing with butterflies, right? Like we'll say the viceroy, the spring beauty or whatever, the monarch, and those we know. But in other parts of the world, they don't call a monarch. They call it the wanderer or something. But birds, I don't think they have that same problem. So if you're a birder, if I'm correct, most of the common names are unique, right? So you don't always have to use the scientific name. So you guys know these birds, and from now on when you go back to stepping stones, you're going to say, oh look, Wilma, there goes a male cardinal. There goes a indigo bunting. Or I saw a Cooper's hawk today eating a chipmunk. Something like that.
Or you can always just get the Sibley Guide to Birds. Yeah.
You could do that too. It's a much easier thing to do. All right, well, we'll see you guys next week. We're going to do something totally different next week. And I'm glad you could come on a rainy day. Anybody have any questions?
Is crow edible?
You know there's a phrase. Isn't there a phrase that you can go eat crow?
Crow is edible when cooked.
You can eat anything if you want to. Crow is not poisonous. I don't think they're... You'd have to eat the pectoralis muscles, wouldn't you? Right? Because they have a big keel. I think you could probably eat crow. It might be a little gamey. I'm not sure. I've never eaten crow. So, in the literal sense of the words. Anyway, yes?
If you haven't eaten crow, have you eaten crow on stick?
No, I haven't. But I'll bet you down south they have, you know. They'll say, oh yeah, we do that in Louisiana, a crow on a stick, you know. Frog on a stick, you know. No, I'm kidding you. They don't do that down there, so don't write in any letters. Okay, so no other questions? All right, so we'll go back out and enjoy the rain and snow on Mother's Day. Isn't that what they said? All right. So we'll see you guys next time, okay? All right. Thank you, guys.